Hello folks, today we're going to be going over the tens in Unit Pack 7. We're going to be introducing you to things called oxidation and reduction. You probably have heard of oxidation before, probably not have heard of reduction, but we put the two together, we call them redox reactions, and it simply involves the transfer of electrons. So these rules are all on your cover. We use these rules when we went over the fives. These rules are going to be used today, so make sure you're using your cover as we go along. So this is the tens. It's talking to us on top that a neutral element has an oxidation number of 0, nothing new. That's what we did on the fives. And ions with oxidation number usually have that oxidation number that's equal to their charge. And again, that's nothing new. We've learned that on the fives. If we have our oxidation numbers actually get smaller from the reactant side to the product side, we call that a reduction. So a reduction in oxidation number is a reduction reaction. And then oxidation is an increase in oxidation number. We're going to introduce you to oil rig. That is on the back of your periodic table, top right-hand corner. We have oxidation is the loss of electrons. So when something loses electrons, that's oxidation. And rig, reduction, is the gain of electrons. So when something gains electrons, that is a reduction. And when you gain electrons, you become less positive, so that is a reduction in number. So here we go. We're going to fill out these 4 boxes based on these half reactions that are on your sheet. So right here we said aluminum, as it would be found on like a chunk of aluminum or aluminum foil, has 0 for an oxidation number. We have aluminum with a 3 positive, and then we have our 3 electrons here. It wants to know if this aluminum right here, is this aluminum losing electrons or gaining electrons? Well, this aluminum right here is turning into aluminum ions and 3 electrons. So this aluminum right here is losing 3 electrons. Oil, oxidation is the loss of electrons. Well, we just said these electrons were lost from this aluminum, so this is an oxidation reaction. We went from a 0 to a 3 positive. That's an increase in oxidation number. And where are the electrons found? They are found on the product side. This is going to help us in a couple worksheets figure out if we have oxidation reduction based on where these electrons are found. All right, here we go. We're going to do another one of these. So we have some sulfur. It's got 0 for oxidation number. We have a charge of 2- on this sulfide. So it's got an oxidation number of 2-. Did this sulfur gain these 2 electrons to become sulfur ion? And the answer is yes. Gaining. You can see a plus sign right there. Literally was added into the sulfur. So rig, reduction, is the gain of electrons. So we just gained these electrons into this sulfur, and so this is a reduction. Our oxidation number went from a 0 to a 2-. That's a reduction in oxidation number, and the electrons are found on the reactant side. That's something that's going to allow us to identify a reduction half reaction. Don't forget, there is a question at the very bottom of your sheet, so make sure you answer that as well. So this is the one we just went over, a nice, neat, clean version of it. I'm going to bring down the next one, pause the video, do the next one, and then check your answers. Then pause the video, do the next one, check your answers, then pause the video. This is the bare bones basics for everything in this unit. If you don't understand how to do this stuff, you're going to have a hard time. So pause the video, do the next problem. There's the answer. Pause the video, do the next problem. Pause the video, do the next problem. Pause the video, do the next problem. And then the question at the very bottom of the sheet that maybe you didn't quite get to, it wants to know when you go from the reactant side to the product side, what happens to the oxidation number in a reduction half reaction? And the answer is it gets smaller. The oxidation number gets smaller as you go from the reactant side to the product side in a reduction half reaction. All right, so again, oxidation is the loss of electrons, reduction is the gain of electrons. That's kind of a big concept you need to learn today. And I also want you to realize that you cannot have an oxidation reaction without a reduction reaction. In other words, something needs to lose electrons and something needs to gain electrons. They both have to happen at the same time. You can't have one without the other. All right, so this is the back side. This first one's been done for you. We got 4 cells that we have to fill in. A couple things I want you to notice. We always put the oxidation brackets on top and the reduction brackets on the bottom. And that's kind of the main thing that I want you to realize as we go through all of it. So this is going to show up on every screen. Do it this way. It'll be easy to correct your assignments using the bins. There's 12 points for doing this work right here. So make sure you do all the work that I'm going to show you how to do. So the first thing we're going to do is we're going to put oxidation numbers above each of the items. So this is a 3 positive, and this is a 0, and this is a 0, and this is a 3 positive. All right, I look at those numbers and I try to find the element or ion that is reduced in oxidation number from the reactant side to the product side. So iron goes from a 3 positive to a 0. That's a reduction. The number's getting smaller. 3 positive to 0. So reduction in oxidation number. So I'm going to write red rather than out the whole word. Reduction is the gain of electrons. So I write gain. And to go from a 3 positive to a 0, it must have been 3 electrons that it gained. Then the oxidation bracket should be easy because it's the other thing that changes number. So I go from a 0 to 3 positive. I write ox for oxidation. Oxidation is the loss, so oil. So oxidation, lose. And how many electrons did it lose? It lost 3 electrons to go from a 0 to a 3 positive. If you did a good job with these brackets, then filling in the boxes is very easy. So this oxidation bracket is right here. It points back down to the aluminum. The aluminum was oxidized. So let me move this back a little bit. Let's try to move this back a little bit. Guess it's not going to allow us to do that very easily. All right, well, I'm just going to continue on. What item was reduced? Well, we have the reduction one going to the iron. I'll just change my brackets a little bit. So Fe3 positive, that is what was reduced. Everything's coming from the reactant side. Nothing is coming from the product side. So oxidizing agent now. So this iron was reduced here. These iron ions were reduced. They needed to gain 3 electrons, which forced the aluminum to lose 3 electrons. So these iron ions right here force this aluminum to be oxidized. So the Fe3 positive is considered the oxidizing agent. This aluminum right here, needing to lose electrons, force these Fe3 positive ions to gain the electrons. So the aluminum forced the reduction to occur. So the aluminum is the reducing agent. I'll show you this again on the next slide. So here we go. Oxidation numbers, 3 positive, 0, 0, 3 positive. I put brackets for reduction. Which element has a reduction in oxidation number? I'm going from a 3 positive to a 0. That's a reduction in oxidation number. So red, reduction is the gain of electrons. So gained, and it must have gained 3 electrons to go from a 3 positive to a 0. The other change in oxidation number must be the oxidation then. So oxidation is the loss of electrons, and this lost 3 electrons. So what item was oxidized? Just got to use my brackets, go follow the bracket back, and we find out that Fe is oxidized. What was reduced? Follow the bracket, Au 3 positive. What's the oxidizing agent? Well, this iron right here was oxidized. This gold caused it to become oxidized. So gold 3 ions caused the Fe to be oxidized, so the Au3 positive is the oxidizing agent. This Fe, needing to lose electrons, forced the gold ions to gain them. So the Fe3 positive caused the reduction reaction to occur. Not Fe3 positive, just Fe. Sorry about that. Again, everything in these 4 boxes will be found on the reactant side. Nothing will be found on the product side. So, pause the video, do the next problem, then play the video. These are skills you're absolutely going to need in this unit, so just don't write down the answers. You're not going to learn anything from that. So there's the next one. Remember, all this work over here, this is worth 12 points total. So make sure you're doing all the work. It does matter if we have a charge on something or if we don't have a charge on something. It's got to be what is on the key, otherwise it would be considered wrong. Pause the video, take a look at this, make sure you understand it, and then go on to the next one. So here is the next one. Take a look at that. After you have your answer down, pause the video, try the next one. You really do need to learn these skills. This one's just H, because if you go to the very top of the column, it's asking what element is being oxidized, and that's H. There's your next one. Remember, always pause the video, try the next problem, see if you got it correct. Pause the video, do the next one. All right, now we're on to the next page. So this one is just saying that bleach is an oxidizing agent, meaning that bleach takes electrons away from stains, and that's why we get a stain to be removed and we get the nice white color underneath it. The firefly is a redox reaction. The electric eel is a redox reaction. All right, so this is another stepping stone to some of the more difficult stuff that we're going to do. Number 1, it asks, what is the total charge on the reactant side? So this side is the reactant side. This side is the product side. We learned that a while ago. So we have 2 of the Cr3 positives, so that's a 6 positive on that side. And what's the overall charge on the product side? Well, we have 1, 2 negative, and we have 14, 1 positive, so that's a 12 positive on the product side. Next one, it says you need to add electrons to the more positive side to make both sides the same charge. How many electrons are we going to add? Well, this side is 6 positive, this side is 12 positive, so I need to add some electrons onto this side, so I'm going to add 6 electrons, and now both sides have the exact same overall charge. They're going to go on the product side. All right, I'll do one more for you, and then that's about it. What's the total charge on the reactant side? 0. And over on the product side, it is an 8 positive. We need to keep the charge on both sides the same. It doesn't always have to be 0, it just needs to be the same on both sides. So then 8 electrons go over here. 8 electrons. And they're on the product side. Again, this is an oxidation. We would expect the electrons to show up on the product side. All right, so pause the video, do the next one. There's the answers to number 2. Pause the video, do the next one. 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 Why don't you do the next one as you pause the video? Pause the video, do the next one. Hope we're getting close. If we look in this problem, this is a reduction, and the electrons are over on the reactant side. So that's something that we want you to start keying into. Last 2 questions, I believe. Maybe not, because we got some more slides to go. All right, we had to do oxidation numbers. So hopefully you pause the video and actually try these. If not, make sure you pause the video and do the next batch. Oop, that went a little fast. Pause the video, do the next batch. And that is all there is. So, have a good day.